Good day, everyone. I want to welcome you to another statistical class. Well, before I get started today, I got some series of announcements. Number one, I've already shared exam one study guide. I needed to check Canvas for that. I uploaded the study guide yesterday. So check the Canvas for detail on study guide. And I also share the venue, the location of exam one. Of course, we all know exam one is going to be conducted next week. And of course, I also share the venue. And I will need you to also check Canvas on that. And those that have completed the makeup form, of course, they're actually going to get there's going to be some announcement regarding that today. So you need to pay attention to Canvas. Pay attention for updates on Canvas. And lastly, my email is working perfectly now because I've already contacted a tech and they fix it within 24 hours. When you send me a message, they can be guaranteed to receive my reply. Okay, so I want to welcome you to my lecture today. The other time we started sampling distribution of statistic, and of course, we're going to continue from there today. And let me also remind you, based on the study guide, the exam one, we actually cover through from chapter 1 to chapter 7, okay, which is, we're actually going to finish that chapter 7 today. Okay, so the focus today will be on option. You need to wait for announcement today. So we're gonna make our announcement. Once again, I want to welcome you to this particular topic. We started this topic I think last week. So sampling distribution, and today we're going to continue from that. And let me also add this. I've uploaded all the links to my recordings. You can now check on Canvas. Okay, or they are up to date. Okay. So I want to welcome you to my lecture. Like I said, we started sampling distribution last week, and of course today the focus is going to be on sampling distribution of proportions. In the outline, of course, I'm going to have a review on sampling distribution of means. Then I'm also going to have a review on central limit theorem and the law of large numbers. And finally, actually going to introduce you to sampling distribution of proportion. So right now, one of four of us starts reviewing sampling distribution. Let me tell you this. When we actually want to conduct study, we normally go into the population. What we want to figure out is what we call population parameter. The population parameter could actually be mean, it could be proportion, it could be variance, it could be standard deviation. But you know what? Because we don't have resources or time to study every element in the population, we normally take our sample size. And when we take a sample and whatever we compute from sample is what we call statistic. And let me tell you this, what we normally want to do, can we have a way to use statistic to represent parameter? And sampling distribution enable us to see how statistic can vary from sample to sample. Okay, if 1,000 investigators who work on the same thing, they collect the same sample size. of course, they're going to have different results. Whether their intention is on computing mean or proportion or variance or standard deviation, that is actually going to have different results. But you know what? The law of large number and the central limit theorem emphasize on something, because through the sampling distribution exercise, we're able to arrive at two theorems. The first one, the law of large number. Now, the law of large number states that if you work with a sufficiently large sample, I'm going to say that again. If you work with sufficiently large sample, your statistic will converge to the parameter. I'm going to say that again. According to the law of large number, if you work with sufficiently large sample, your statistic, when I say your statistic, it could be sample mean, it could be sample proportion, it could be sample variance, it could be sample standard deviation. All of that will converge to their true value of parameter. And that's what we mean by law of large number. But you know what? On the other hand, the central limit theorem does not talk about convergence of statistic to parameter, but that's only talk about the convergence of the distribution. So the central limit theorem states that if you have a sufficiently large sample, even though the underlying probability distribution of the population may not be normal, but when you take a sufficiently large sample, then the distribution of the statistic, whether the mean or the proportion, is actually going to be normal. And this is what I'm trying to show right now. For instance, we actually want to find the mean, and if we want to find the mean, I said we have found the mean and the standard deviation of the sampling distribution of X bar. Of course, we did that in this class. And I'll say, however, as when we exploit the probability distribution, we would like to know the shape of the sampling distribution. Some of you may be wondering, why are we interested in, why are we seeking to know the probability distribution of statistic? Because statistics vary. When something varies, we want to know the probability distribution for us to be able to see the shape. We want to see the shape, whether it's going to be normal or not. If it is normal, if it is not normal, of course, if you follow the idea of central limit theorem, taking a sufficiently large sample, it's actually going to be normal. And why is the interest on normality? The interest is on normality because normality facilitates standardization. When I say normality facilitates standardization, it actually means with normality, we'll be able to make use of a z-score. And of course, when you're making use of z-score, that actually comes with simplicity of computing probability. That is just the idea. Now, if I take 1,000 separate samples, each of size n, what do I mean here? I need you to pay attention for you to be able to see what do I mean. If 1,000 researchers or 1,000 investigators should go into a population and choose the same sample size, of course, they're actually going to have 1,000 different means. And after having that, actually, I said for each sample, calculate the average time per day spent watching TV. Okay. And I said this gives us 1,000 independent sample means. This accounts for the reason why researchers actually have different results when they are working on the same goal. That can be attributed to sampling error, because the participants in my cohort, is different from the participants in your cohort. Now, because of the fact that we're now going to have 1,000 different means, then for us to be able to talk about the spread, or we want to talk about the center, we actually need to construct the histogram. Of course, in this class, we actually, if we want to have idea of the probability distribution, we normally construct histogram. Now, I need you to pay attention now, okay? I really want you to see how this with central limit theorem, we're able to deduce that last sample work in terms of distribution. Now, I need you to pay attention now, okay? Now, don't forget, we go into population 1,000 times, but in each occasion, we choose sample size of 10. Okay, in each occasion, we choose sample size of 10. That is the histogram. When we decided to increase the sample size to 100, you now see the shape that's shrinking. The other one spread out. Okay, when it's shrinking, it's actually telling you that the standard deviation, the standard error is going to be small. We don't want spread out. We want this to shrink in. Now, when we continue to increase the sample size to 500, you're actually going to see that the error in this one, in the one with the 500, is the smallest. And that's exactly what we want. When standard error is very, very small, of course, that will validate our statistical inference. So if you take a look at what is on the board, it is not only about the convergence of the distribution to normal, but we also were able to see the performance of the shape in terms of, whether it's going to shrink in or it's going to spread out. Now, what I need you to see, I said something the other time. I said, whether irrespective of the sample size, I remember I said on Wednesday, the mean of the sampling distribution of mean is going to be equal to the population mean. Initially, the population mean, it was 3. If you take a look at this guy now, okay, take a look at the center, it is the same, it is 3. If you look at the center here, it's also 3. If you look at the center here, it's also 3. They're all going to have the same mean, okay, irrespective of the sample size. But what is the difference? The difference is just going to be the standard error. The one with a larger sample size, we have a smaller standard error. Does that make sense? And that is that. Now observation continues. Number one, I said our sampling distribution has a different shape than the population distribution. And the sampling distribution is going to have a different shape depending on the sample size. The more sample you take, the more you're very close to the truth. That's what we mean. Okay, now the second one, going to have a bear shape, going to appear normal, and that will be centered around 3. As you can see, all of that centered around 3. Okay, and you know what? And it will become less variable as sample size increases. Less variable as sample size increases, more variable as sample size decreases. Does that make sense? Okay. Now I need you to pay attention. You remember the other time when we're working with normal distribution, when I write random variable S, we normally have follow normal. Please, I need everyone to pay attention. If you listen carefully in my class and you ask questions when you get stuck, you're actually going to pass my class excellently. Now, I wanted to see the connection between what I wrote. Okay, let's take a look at this guy now. I'm talking about individual X. I'm talking about individual. Okay, we next follow normal distribution. Okay, it has a mean of mu and a standard deviation of sigma. But if I'm no longer talking about individual, I know individual varies. Not only that, the sample mean also vary. If I want to talk about that, I'm actually going to be talking about this if you follow normal distribution. The red one, it is individual X. The second one, average. Sample mean, follow normal distribution. When you compare the two, they have the same center. They have the same mean. But the difference is they have different standard deviation. If the individual one has sigma, the X bar has sigma divided by root n. I needed to pay attention to that. And let me tell you this. What is the condition under which the sample mean will follow normal distribution? The sample mean that we talk about will follow normal distribution depending on the sample size. But you know what? According to the central limit theorem, okay, you know, when it said for a sufficiently large sample, of course, the distribution of the sample mean will be normal. And the question is, how large is a large? And it gave us a threshold. He said, the rule of thumb, when sample size is at least 30, okay, when sample size is at least 30, of course, the statistic will follow normal distribution. But let me tell you this. I need to pay attention now. If the population distribution is normal, let's say the population you want to choose from, you want to choose sample from, is already normal, irrespective of the sample size that you choose. The sampling distribution of statistic will be normal. I'm going to say that again. If the population distribution you're choosing from is normal, okay, irrespective of the sample size, whether you choose small sample or you choose large sample, the statistic will be normal. But if the population distribution you are choosing from is not normal, I'm going to say that again. If the distribution you are choosing from is not normal, before the distribution of the statistic can be normal, you need to choose a large sample. And how large is a large? It has to be at least 30. Does that make sense? Okay. I want us to have an example now. I want you to see the difference between how we compute probability with individual random variable that follow normal distribution, and we were focusing on the mean that follow normal distribution. Now, a machine fill empty glass bottle with soda. Let X be equal amount of soda poured into a bottle, and assume S is normally distributed with a mean of 298 ml and a standard deviation of 3 ml. Now, I need you to pay attention to the question right here. You have been told that the random variable S follow normal distribution. And let me tell you this, if a random variable S follow normal distribution, whatever sample size you take, if you want to conduct a statistical inference around the sample mean, it's going to be normal. Okay, now the question said, the label on the bottle says that it contains 295 ml of soda. Find the probability that a randomly selected bottle contain less soda than advertised. Now, we are focusing on individual here, just one. Okay, now we're focusing on one. Your attention will be on random variable X. When you're focusing on more than one, your attention will be on the mean. Okay, now this is what I want to find. I actually, mathematically speaking, I can actually interpret that as probability of S less than 295. Then I'm going to do my standardization. Okay, the formula for standardization now that I'm actually going to use for individual is actually going to be Z equal X minus mu divided by standard deviation This is for the individual one. And that's exactly what I'm applying here. At the end of the day, when I'm trying to tell the world, we got a negative one. Then we are trying to say the probability of S less than 295 is going to be the same as probability of Z less than -1. Go ahead. Say that again. Okay, you don't need that in the exam. We're going to make a provision for code P norm. You know, here now, if I want to get probability of Z less than -1, I'm just going to write P norm into -1. So in the exam, if you look at that practice question, we're going to make suggestions to you. You are not going to use arrow in this, sorry, you're not going to bring your laptop. We don't need your laptop. So what we're going to do, for instance, now, maybe you want to solve this problem. We're going to say, we're going to make some suggestion. We're going to write P norm, -1 equal, we're going to put a particular value. We're going to write Q norm into -1. So it is now left for you to choose which of the code is the correct one. Does that make sense? So if you take a look at the practice question, and that's why attendance on Monday, very, very crucial. Your attendance on Monday, because you know what I want to do on Monday? We want to go over those practice questions. And I'm going to walk you through that one after the other. Okay, have I answered your question? Okay, yeah. Yeah, there's going to be combination of multiple choice and short answer question. But the one that involve how, we will definitely make a suggestion for you. And that, you know what I'm advising you to do before Monday, because I know most of you've not really opened the exam one practice. Because in the exam one practice, you're actually going to see the opportunity. You're going to see, you know, the way the suggestion about arrow code is mentioned. Does that make sense? Okay. Now, right now, I'm only going to write P norm into -1, and that will give me that. But you know what? Like I said, in the exam, we're going to write P norm -1. We're even going to write 1 minus P norm, something, you know, we're just going to make some suggestion, and it is now left for you to figure, you know, to use the right code. Does that make sense? The code will come with answers. Does that make sense? Okay. Now, this gives us 0.1587. But you know what? Another question now has, now find the probability that average amount of soda per bottle in a randomly chosen six-pack is less than, now take a look at this. We're focusing on average now. We're no longer focusing on individual. We're focusing on average, okay? Then this is what we want to find. We want to find the probability of X bar this time around, not probability of X. Then we're going to do standardization again. But to do standardization, your Z, when the random variable is sample mean, your Z is going to be X bar minus mu divided by sigma over square root of n. Do you see the difference? When we're dealing with the individual one was X minus mu over sigma. For the average one, it is X bar minus mu over sigma over root n. Please take notes. Now, after standardization, I got this. Probability of Z less than -2.45. And moving forward, what I'm only going to do, I'm just going to write P norm into -2.45. And that will give me 0.0071. Now, you now see when we calculate the probability of S less than 295, the answer, the value that we got is different from when we calculate the probability of X bar less than 295. Now, how do we interpret? If you want to get a full grade in the exam, make sure you interpret when they ask you to do so. Now, take a look at this. How do I interpret this value? And how do I interpret that value? I needed to pay attention. If you want to interpret probability, you need to multiply by 100. It makes more sense interpreting in percentage. Look at what I said. only about 1% of any sample six-pack. If you want to interpret probability that has to do with the mean, you need to mention the sample size you talk about. Don't forget, we know to arrive at 0.0071, okay, we actually use a sample size of 6. You have to mention that. And that's what you're seeing here. I said only about 1% of any sample six-pack. We have an average amount less than 295. Okay, but how do we interpret the individual one? I said whereas almost 60% of individual bottle are under fill. Where do I get the 60% from? Okay, from here, you multiply the answer here by 100, approximately 60%. So you see the way we interpret the two. Okay, now I want to go into more example. Suppose the mean number of children per household in the United States is 1.90 with a standard deviation of 1.68. The numbers are based on the 2006 General Social Survey. Let X be number of children in a household. And the question asks, does X have a normal distribution? Of course, no. The reason why no, we're talking about the number of children in an household. Number of children can be counted. Therefore, it cannot be continuously discrete. And if a random variable is discrete, then it can never be normal. Does that make sense? That was why we said that. Look at the way we are, let your answer be short. Does that make sense like that? Now, question 2 said, let X bar be average number of children. Now, we want to talk about average. Right now, average number of children in a random sample of 50 household. Please pay attention. In a random sample of 50 household, what is the sampling distribution of X bar? Right now, what you need to do, if you want to answer a question about the sampling distribution of X bar, let your mind go to central limit theorem. What does central limit theorem say? The central limit theorem say if the sample size is at least 30, then that statistic can be approximately normally distributed. Right now, sample size of 50, which is greater than the threshold. Don't forget the central limit theorem. Actually put the threshold as 30. Now, what you're going to write now, you're actually going to say yes. You know what I mean? X bar follow normal. Where's the 1.9 coming from? The 1.9 is the mean that they mentioned. Then the standard error is going to be sigma over square root of n. Does that make sense? Now you can see we started with non-normal. We started with non-normal population, but we ended up with a normal population. And how do we end up with a normal population? Because the sample size is greater than 30. Does that make sense? That's how to do that. Now, this is another question. Sample 50 household. Find the probability that the average number of children. Now, the random variable is the average number of children. Okay. Now, in this sample, it's more than 5. Now, the mathematical interpretation for that is, I want to find the probability that when I go into any household, on average, the average will be more than 5. Okay. Now, I'm actually going to do standardization. Don't forget, I'm working with a group level now, not individual level. So, of course, I'm still going to have mu, but here is going to be the standard error, which is standard deviation divided by square root of n. And at the end of the day, I got this guy. And when I got PZ greater than 13.05, if I want to run this in R, it's going to be 1 minus P norm 13.05. You know why 1 minus P norm? Because I'm dealing with the greater than, and that will be 0, very close to 0. And what is the interpretation? Because the probability is very close to 0, that is going to be highly unlikely that any sample of 50 households. Please pay attention. Whenever you want to interpret probability, it has to do with the mean. You have to mention the sample size. Now I said it is highly unlikely that any sample of 50 households will have an average number of children that is bigger than 5. It is unlikely because the probability is more or less 0. Now I want to use the rest, the remaining 22 minutes now. Go ahead to focus on sampling distribution or proportion. Oh, you say what? No, 1 minus P norm. Why? Greater than? Don't forget that when it is less or equal to, when it is less or equal to, it's going to be P norm. When it is greater or equal to, it's 1 minus P norm. Does that make sense? Go ahead. Yeah. Okay. If I hear you correctly, you're trying to like, how do you implement that now, right? Yeah. Now, this is it. You can't use R on the test. Like if we're gonna ask this question, we're gonna make some suggestion. We're gonna write P norm into 13.05 equal to a particular answer. We're gonna write Q norm, the same value. So we're gonna make some suggestion that you will be one that will now look at the one to you that is appropriate. Exactly. And that is the reason why Monday's class, next Monday's class, I want to appeal to everybody. You know why I want everybody to pass my class excellently? If you attend the revision on Monday and Wednesday, you will you will pass this exam excellently. Because I'm actually going to walk you through practice questions. And in the practice question, we have some suggestion about the R code. Does that make sense? Okay, go ahead. Okay. If you I uploaded study guide on the Canvas. The study guide, the exam is going to cover chapter 1 to 7. Everything that we have done from day 1 up to today. Does that make sense? Chapter 1 to 7. And if you want to see that exclusively, I will advise go to the Canvas, open it. You're going to see for chapter 1, the area, chapter 2, and so on like that. I uploaded the study guide yesterday. Okay, now because of my time, I quickly want to move to sampling distribution of proportion. Let me tell you the idea that we use in the sampling distribution of the sample mean, we're also going to use it for the proportion. Now, I demonstrated to you the other time, if, of course, election is around the corner in the United States. And of course, because we are actually curious, we want to secure our political environment, we really want to know whether what is going to be the chance of maybe our candidate. Of course, if you listen to ABC News, the cable network channel, they're going to say, okay, the probability that this person is going to win is 51%. If you go to CNN, they will report different value. If we go from one channel to the other, they report different values. All values that they report is what we call sample proportion. The same way sample mean varies, sample proportion varies. And what is our intention? Our intention is, okay, P is what is population proportion of success, which is the population parameter. P cap is the statistic, which we call the sample proportion. Now, since we don't have resources, we're limited by budget to study everybody in the population, we normally end up getting P cap. Now, we're going to use the idea of sampling distribution. How can we use P cap to represent the population parameter? Okay, the same idea. Now take a look at example 7.7. Suppose we take a random sample of 60 US household and 7 say they've been burglarized, robbed. Use this information to estimate P, the true proportion of US households that have been burglarized. Now, let me tell you this. When you take a look at this, we normally talk about proportion when the interest is on certain characteristics of interest in the population, which is more or less like categorical. Right now, we want to know how many Americans have been burglarized, but we don't have access to the whole population. Now, we choose a sample size of 60, and out of 60, of course, we're going to be asking them question of yes or no. Have you been burglarized? Yes. Have you been burglarized? Yes. Have you been burglarized? No, 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 no. Yes, yes. I count the number of yes. The number of yes here is actually going to be the number of successes. And that will be 7 over 60. That's 7 over 60 is 0.117. If I ask each of you to go into the American population, choose randomly 60 people, ask them this question, you're actually going to have different results. The same way sample mean vary, the sample proportion also vary. Okay, what is the goal? Like I said, p-cap vary from sample to sample. The same way sample mean vary from sample to sample. And how can we ensure the convergence of the sample proportion to the population proportion? Then we're also going to use the idea of law of large number. The idea of law of large number was used for the convergence of sample mean to the population mean. And right now, we are also incorporating the other idea here. So this guy is trying to say, when you take a large sample size, okay, when you take a large sample size, okay, the sample proportion will converge to the population proportion. And you know what? Because of that, we're also going to have a way to find what, because the proportion varies. The proportion that you get is going to be different from mine, is going to be different from this guy. Everyone is going to have different value for proportion. Then what we can do, we can find the average. And that is what this guy is trying to say. Mean. Mu p-cap means the mean of the sample proportions. You got a lot of sample proportion. And that mean is always going to be equal to the population mean. Now, with the idea of a sampling distribution, because the sampling distribution emphasized we go into population several times, it actually acknowledge the fact that researchers, several investigators will get different value for sample proportion. And because of that, since we're going to go into population once, then we have a formula to figure out the standard error. And this is the formula. So what this formula is trying to talk about, the standard deviation of sample proportion that we call the standard error now is actually going to be the square root of p into 1 minus p divided by n. Now, this is it. If we take a lot of samples and calculate p-cap for each, the average of p-cap will be close to p. Why am I finding the average? Because this guy has a different p-cap with mine. My p-cap is different. Your p-cap is different. Then can we have a way to harmonize situation? And that is the reason why when you listen to the news, they're going to tell you CNN Post, New York Post, Olympia Post in election, and they're going to say this is the average of the national polls. Okay. Now, we just talked about the law of large number. The law of large number enables us to see the number of samples we're going to take before the sample proportion convert to population proportion. But you know what? We also need a central limit theorem because of the fact that we want the probability distribution to be normal. And the central limit theorem is going to impose a condition. The other time when we were working with the mean, the condition was that the sample size has to be at least 30. But when we're working with the proportion, oh my God, the condition is different. The product of N and P and the product of n and 1 minus p must be at least 15. How did they get the 15? Oh, they got it 15. When you take a look at P, right? What is the middle of 0 to 1 is 0.5. Multiply 0.5 by 30. What does that give you? 15. Okay. And multiply by P has to be at least 15. Okay. Now, if that happens, then we can now boastfully say P cap as a random variable follow normal distribution with a mean of P and the standard error of that. Now let's go into the example right now. And I need you to pay attention now. Suppose that 29% of University of Minnesota students feel that our campus is becoming more dangerous. Take a sample of 100 university students and let P cap be the proportion of sample that feel campus is becoming less safe. Now the question now, find the mean and the standard deviation of the sampling distribution of P cap. Now, if I want to find the mean, I told you all the time, the mean of the sampling distribution of statistic is always going to be equal to population mean. The population proportion given here is 29%. That's 2.29, and that would be that. Now, if I want to find the standard deviation now, I'm actually, don't forget, I'm going to use this particular formula now. Okay, I know what my P is. I know what my sample size is. I'm just going to plug that in, and that's going to give me 0.45. Now, another question is going to say, what is the approximate sampling distribution of P cap? I needed to pay attention now. I'm seeing a lot of exam questions. Pay attention. Now, what is the approximate sampling distribution of P cap? Do you know that when you look at the question initially, there is no any area in the question where they mention normal? Is there any area in the question where they assume normality? No. Which means the distribution is not normal in the first place. But let us now see whether the distribution is going to be normal, and what you need to pay attention to when the distribution is going to be normal is look at the sample size. What sample size do you see? 100. Okay. Now, you want to ask a question? Okay. Because of my time, I will reserve that question for next week. Monday, Wednesdays, we got a lot of time. We're not going to have lecture. We're only going to be having revision. We're going to discuss a lot of stuff about the exam. Sorry about that. Okay, now, then I'm actually going to write this guy because I see that if you want to know whether I follow normal distribution, you need to investigate this guy. Is n multiplied by p greater or equal to 15? And not only that, it is n into 1 minus p also greater or equal to 15. Now, in this case, your n is 100 multiplied by 0.29. Okay, that will be greater than 15. Because of that, then you can now solve it and write it that way. Now, the next question, select one person at random from the sample of students. What is the probability that this student feel campus is becoming more dangerous? It's still going to be 0.29. Now, another question asks, what is the probability that fewer than 20% of those surveyed feel campus is becoming more dangerous? Fewer than? Okay, it's going to be, you want to find the probability of a P cap less than 0.20, and you're going to standardize. Now, in your standardize right now, the z-score formula here is going to be P cap minus P divided by square root of P, okay, into 1 minus P, okay, divided by n. That's exactly what we use, okay? And if you take a look at this, when you solve that, we got the probability of z less than -2. And of course, the moment I write P norm into -2, I'm actually going to have 0.228. And if I want to interpret that, I'm going to multiply that by 100. That will mean about 2% of possible samples of university or student will have a sample proportion less than 0.20. Let me give you this another real life example, and I need you to pay attention now. Pfizer claimed the other time that they developed a vaccine for COVID that can prevent infection rates. And they put the efficacy rate of their vaccine to be 95%. Now, let me tell you this. I need you to pay attention now. Efficacy to be 95%, they are trying to tell us population parameter P is 0.95. Now, if you want to investigate with that particular value, why can't you go into the population, select those who have been vaccinated? If I ask each of you to go into the population, select 10 that have been vaccinated, okay? Now you can't, how many of them, after being exposed to COVID, how many of them prevent the occurrence of COVID? Maybe when you do your investigation, when somebody do an investigation, it may say only 50%, somebody may say 70%, somebody may say 80%, somebody could say all of them. That means statistics vary. Now, what if I don't want to find this? If I realize that the P cap is normal by central limit theorem, how am I going to know whether it's normal? If each of you choose a sample more than 30, okay? And I will want to find what is the probability that the efficacy will be less than 80%. We can compute that. So that would mean the probability of a P cap less than 0.8. And if you want to do that, we're going to standardize like this. We're going to make use of P cap. In that situation, the first P cap here is going to be 80% that we mentioned, is 0.8. The P without a cap will be the efficacy claimed by Pfizer vaccine. That will be 0.9. And in the denominator, I'm actually, be careful with what you're going to put here. That P that you see here is not a P cap in the denominator. Okay, the P cap is actually that very P is 0.95 is going to what you're going to put in the denominator. At the end of the day, you get your Z. The moment you get your Z, you can actually compute that in out, and you can tell the world if a Pfizer claim their efficacy to be 95%, this is the probability that the efficacy will be less than 80%. We're able to do that because of the help of the sampling distribution. Okay, so what is next? Oh my God, what is next is revision, and I need you to be around on Monday. And you know what? To be around on Monday, you need to come to this class with the exam exam 1 practice question, because we want to go over the exam 1 practice question, trying to work. Some of you have been asking questions about, are we going to make use of software in the exam or not? We are not going to make use of software in the exam, but there's going to be suggestion about our code, and I need you to be around on Monday. We're going to walk through that together. We're going to discuss about what are the materials that are permitted, that you can bring to the exam, or what are the things you can do, what are the things you cannot do. I want to say this authoritatively. If you attend the revision on Monday and on Wednesday, you have a chance of scoring more than 100% in the exam. All what I just need from you is to be around. And I'm also going to record that section as well. And I'm also going to post that section as well. Oh, it's another weekend, right? Make sure you all stay safe and have a lovely weekend. Bye for now, everyone. You're welcome. And you too. Oh, I love that. Yeah, my daughter do sports too, so I understand. You know what?
I will advise you much to me. I'm actually, yeah, like right now, I've posted all reports.
Okay. Like, I'm going.
Exactly.
Take the notes.
You should be perfect.
And I'll be here when.
Yeah, probably. No, it's gonna take because we got a lot of questions.
Yeah.
And a lot of information, but I'm actually going to dish out, so Mondays, Wednesdays, and of course, the following day.
Yeah.
It'll be exam.
So
Yeah.
actually, Wednesday class, when I was going over the notes, I didn't understand this portion there.
Oh, okay.
I
yeah,
didn't
this-
understand this portion.
Oh,
Why
okay.
from here, it's, how did you get this?
Okay, so this one is just like, okay, I have 4 people. I will choose 2.
Mhm.
This is to tell you the possible numbers of 2s. Like maybe I ask you to go into the population, there are 4 people,
Mhm.
and I want you to choose 2 people
Mhm.
in terms of their age.
Mhm.
And there's possibility the first you may choose 18, like another person may choose 18, 20.
Okay.
So we're just talking about the possibility.
Okay.
And when you find the mean of each one, you're gonna have this.
Yeah.
So this is telling you there are 16 possible means.
Then why here N is 4?
Exactly. This one is when I have access to the whole data and I want to find the population mean.
Okay.
So what I'm trying to do here is to be able to show at the end of the day that the population mean
Okay.
will be the same. It's gonna be the same. Continue. It's gonna be the same as that.
Okay, so in this one, this is X.
Yeah,
This is X bar.
exactly.
Okay.
So the one that was X,
Mhm.
the distribution is not normal for uniform.
Okay.
Finally,
It became,
it became normal.
okay.
And when it became normal, they may remain the same,
Mhm.
but there is something that doesn't remain the same, the standard deviation and the standard error.
And one more thing.
Yeah.
Is this related to the N should be greater than 30 to use central?
Yeah, this is just saying that it should be greater than 25, but on the actual sense, it should be 30 or more.
30 or
30 or more is greater than 25, so
Mhm.
yeah, it has to be at least 30.
And so in the exam, they will give at least minimum 30 to make it
No,
use the
no,
center.
no, question, that may be a question too, that, okay, what is the distribution of this? If the population is not normal
Mhm.
and the sample size does not meet the threshold,
Mhm.
then you're gonna say it's not normal.
It's not normal. That
So
is-
it depends on the.
Okay, it depends. Okay,
Just watch out for that threshold.
yes, okay,
Yeah.
thank you.
You're welcome. How are you? I'm good. Okay, I should black it to like, which, okay, you're welcome. Oh, is that what you want to ask me, right? Okay,
Okay, so the concept earlier on my second assignment.
Okay.
On how it was like the PA commented that he wasn't able to see it. So I emailed it to him again on like a PDF file and I CC'd you on it. But you probably sent it to my TA, so do I email him again or?
yeah, since my email started working perfectly yesterday.
Oh, okay.
So what happened is, forward my comment to the TA. Since you already have your solution,
Okay,
then it should great. You have my permission, so
okay,
yeah. But just forward my response.
okay,
Yeah, you should be fine.
okay, that's how the
Yeah,
question.
yeah.
Thank you.
Yeah,
I'm
how are
just
you?
wondering, this might be a little bit outside of what we're,
No, go ahead.
but how do we know the amount of samples to like assume the whole like central limit theorem, I think, or just like. It's because we do the mean of all the samples is equal to the population mean. How do we know how many samples we need to like assume that? It's because I assume if we take 2 samples, it could technically be called a sampling distribution. But that probably wouldn't accurately represent what the actual population.
Okay, so you like you're trying to like how did they arrive at least 30, right?
That's just for the sample size though. What
Yeah.
about like, it's because, whatever, like sampling distributions, it's just a collection of a bunch of different samples.
Exactly.
So how do you know how many samples you need to put together into a sampling distribution to,
That's a good question. That was what we did behind the scene.
yeah.
We know we're not going to go into the population more than one time.
But what does that mean? What you mean,
Okay.
like you only go to the population?
This one, I want to go into the population to ask maybe like, okay, this class now, the whole class is population.
Mhm.
But I don't have time to study everybody.
Yeah.
I only want to choose a sample.
Sure.
Now, if I choose 10 and I find the mean.
Yeah.
And you choose 10 from the same population and you find the mean, she choose 10. If let's say 1,000 of us go into the population
Yeah.
and choose 10, we have different means.
Mhm.
Now, when we have different means, we now need to look at the distribution.
Yeah.
The probability distribution. Why are we looking into that? Because we want to see, is it normal or not? Now, what is going to make it to be normal? Let's say, for instance, the original distribution of this guy is not normal. I'm just assuming.
Hmm.
Let's say, how do I know it's not normal? Or let me just say, in practice, we may not even know what
Sure.
distribution of this class is going to be.
Yeah.
Now, what we're going to do, what we have done in sampling distribution is when we choose sample size of 10, when we choose 20, when we choose 50, when we choose different sample sizes, we're looking at the histogram.
Mhm.
Now we now realize that when it is at least 30 sample size, it will become normal. And that, I mean the distribution of the sample means. Okay, so when it is now normal, okay, that is why we now say, okay, if you want, since we're going to go into population once, okay, now what you're going to do is, if you can take at least 30,
Yeah.
then you can be guaranteed that your mean, your sample, whatever sample mean you get, will behave well.
Sure.
That's exactly what we mean.
Yeah.
So
And
that
there's
is,
probably like a bunch of math behind that, right?
there's a
like-
bunch of math behind that. But a bunch of math behind that, we're not disclosing that because it's beyond the scope of
Yeah.
this class.
Sure.
Like if you take a higher course in statistics, you're actually going to see a lot of derivations.
Sure.
I understand where you're going.
One
Yeah.
more question, the homework, can you upload the answers for the assignments, can you upload the solved answers for the assignment?
Oh, so you don't have access to the solve.
Solution.
Yeah, okay. I think I'm going to do that before the exam.
Yeah.
What we're trying to do, because there are some students that have a late submission,
Mm,
we don't want them to go and copy.
yeah, because I'm only getting the grade, so I don't know where or
Oh,
where
yeah.
exactly.
Yeah,
it's at. I asked my TA
Yeah.
during class, he's like, I will see and I'll let you know, I just wanted
No, we'll do
to
that.
see if it's.
We'll do that. We'll let all students see the solution.
Okay, thank you,
Right, so
thank you.
you're welcome.